You're not using all-time version. Michael, can you hear me?
Yes, I can.
And now
Good.
Aaron's up.
Let's wait 1 or 2 minutes before people come back from break. Okay. Do you have Martin here? Martin?
Are we looking for Martin Duke?
Hmm?
Are you looking?
Yes, I'm here.
He is on.
Oh, okay. Oh, okay. He's a remote.
Or no,
I
And
see.
Martin,
I see. Thank you. Okay. Shall we start?
I think so.
Okay. Okay, let's get started. Welcome. This is TCPM working group meeting. Please make sure you are in the right room. My name is Yoshi Nishida, one of the co-chair of TCPM working group. And we also have Ian here and Michael on remote. And please note, this session is being recorded and will be published eventually. This is user note web. I think you are already familiar with this one, but just in case, this is a reminder of IETF policy about how to participate or how to contribute to IETF. If you have any concerns, please read this draft carefully, and you can find the same content on the IETF webpage. And this is the tips for this IETF meeting. If you participate this meeting from the venue, please make sure to sign in the session by using Meet Echo. And when you join the mic queue, please use Meet Echo application. And if you are using on-site, non-on-site version, please make sure keep your audio and video off. And also, please wear a mask unless you are not actively speaking at the microphone. And if you are participating this meeting from remote, please make sure your audio and video off unless you are not speaking or presenting something. And we, try to recommend you use your headset if possible. Okay, and logistics. As we are looking for note taker, but thank you, Momoka Yamamoto, for volunteering note taking. Thank you so much. And if it could be good if we have second note taker. Thank you. And the mic will take care of Java. Thank you. And this is short reminder. When you submit your internet draft, please make sure put TCPM in your internet draft so that we can track the status of your draft. And this is the agenda for today's meeting. We will start from working group status. And after that, we have two presentations for the working group items. First one, Bob will present accurate ECN and ECN++ draft. And next, Curtis will talk about TCP accurate request. After that, we have two presentations for non-working group items. First, Wei and Asian will talk about service affinity solution for TCP-based application. And next, Yoshi will talk about aggregated option for scene option space extension. Any comments, questions, or suggestions to the agenda? Okay, if not, moving on to the next topic, working group status. So we are about to finish 3 working group items. First one is Young TCP, and the next one is 8312 draft. This is cubic specification. And then last one is HiStat++. And these 3 drafts are in RFC editor queue for now. So they will be published very soon. We appreciate your cooperation and the contribution. And we also have several working group items. The first one is accurate ECN. As you might know, we are currently running working group Rustco on this draft. And we will have a discussion on this draft in this meeting so that we can confirm that we can conclude the working group, conclude the working group Rustco, or if there are another remaining items for this draft. The next item is generalized ECN. We will have a discussion on this draft in this meeting. In the chair's thinking, when we can conclude the working group Rustco accurate ECN, then I think we are start thinking about running working group Rustco for generalized ECN. But yeah, in any case, we will have a discussion on this draft in this meeting so that we can check if this draft is ready for working group Rustco or not. The next one is accurate request. We can discuss this draft in the meeting. And the next one is 6937 draft. I think, so unfortunately, we don't have a presentation for this meeting, but I just received the slide from the author in this meeting, so maybe I can quickly share it. Where is it? Yep. So this is one page slide for 6939 draft. So I think 6937 has been published about 10 years ago and as experimental RC. But after 10 years, we have many implementations in Linux, FreeBSD, Netflix, BSD, or Windows. And so there are some voice that we want to make PRR as a proposed standard. That's why we are working on it. And then I think this draft has been stable for a long time. And then recently they have some updates on this draft. But and then just this morning they have updated new version. I haven't had enough time to review this new version, but according to the author, there are many clarifications, but not technical changes. But it would be great if we can read new draft and provide a feedback. So any questions or comments on this draft? Okay, if now, moving on to the next topic. And just right. Share. And then next working group item is EDO. So I created one slide for this slide for draft. So EDO draft has been around for a long time. And then we need more feedback on this draft to think about how to proceed the draft. And last week, Michael gave us very detailed comment on this draft, which is very great. But it would be great if we can get more feedback. And in the previous meeting, when I brought up this topic, I think several people showed some interest in providing a feedback on this draft. So if you still have interest, please feedback on this draft. We really appreciate for your contribution. And at the same time, we would like to understand if there are any blockers for this document. So the reason why people do not want to proceed document is that we don't have a specific implementation. Is that the reason? Or the intended status of this draft is the blocker for this draft? If we change the status of this draft, people can be happy? Or is there any other topic that people do not want to proceed this draft? If there is any blocker, this is a good time to share the opinion. So if you have any comments or thoughts, please speak up right now. Any comments on EDO draft? Nothing particularly. Okay, so in this case, let's move on to the presentation. Bob is here, or Bob is from remote? Okay, Bob is remote.
Hi there, can you hear me?
Yeah.
Good. Thank you very much, Yoshi. There's the title and authors and draft name of the Accurate ECN work, which I'll be presenting next. Can I control this or do you? Could you give me the next? Yep. So I'm going to skip over the first two slides, which are just for the record, what the problem is and what the solution is as a recap. Can you go straight to slide 4? Next, please. Keep going. Right. So since the last IETF, I'll just give it a recap of what's been happening. We had draft 22 then draft 23 in February. That was updated because Apple were implementing it in their operating systems and found a couple of places where it wasn't clear what they had to do. One was there's this thing called the handshake encoding of the 3 bits, the 3 ECN flags in the TCP header, and it wasn't clear that you also had to use that we were acknowledging a retransmitted SYNAC because there is some quite complex wording around when you transition into an established state, what you do. So that was made clear. And the detection of loss of a pure ACK wasn't clear. You know, for instance, if a TCP option on there is causing all pure ACKs to be lost by some mangling middle box, that's all well and good, but you can't really tell when pure ACKs are getting lost other than by detecting that you keep getting retransmissions because the other end isn't getting your ACKs. So that was necessary to write in, although sort of, I mean, you know, the people implementing it knew what to do. It's just needed it written in for completeness, and that just fixed a number of nits. Next slide, please. So we had, as Yoshi said, the working group last call finished on Friday officially, but as is often the case, we had 2 more reviews on Saturday and Sunday, which is fair enough. The first 2 reviews, one from Michael, thank you very much, and I've resolved that all with him off list, given him a diff, and he's happy with all the changes. Just a brief recap of the conversation on the list about that. We had to just make clear where exactly we were talking about in the TCP header flags, but we used the bit offset terminology for the flags that are now in the new TCP RFC, which I still can't remember the number of, and also the same terminology that IANA now use. Just to be clear, specified that the option counters are big endian, and which end the lowest significant bit was in the ACE field, and also Michael found a rather embarrassing point in the summary at the end where we used IP header instead of TCP header, which has been there for 12 years with no one noticing it. And finally clarified the request to IANA regarding the experimental ID assignments that were in there during the experimental phase of this draft, and making sure that they refer to this RFC. And in fact, Alex pointed out that we had left one occurrence of the word experiment, which has been taken out. So this is all editorial stuff, really, but it's good stuff. And I found that we'd described multipath TCP as experimental when that's now gone to standards track. So that was all sorted. Next slide, please, Yoshi. Right, so the 2 more recent reviews, Gori's sent a very useful, very long review, which I've worked through on the list. We've had, I think, 3 rounds now, and Gori's now agreed to all the things I've proposed to change, and I've now been working through changing them, but I haven't quite finished. Trying to summarize them all is rather difficult to do briefly, but I guess a lot of them are to do with Gori checking which actor we're talking about for each requirement, whether it's the data sender, the data receiver, the host, the client, the server, and there's quite a lot of it as well, which Gori wasn't sure of in some cases. I think most of the cases, the text was correct, but Gori was just checking. He found 1 or 2 that weren't, so thank you, Gori. And the second point that I'd like any feedback on the list about this, actually, we've got a section, the main section of the document, section 3, which is the specification of the protocol, has a final subsection about proxies, offload, and other middle boxes, section 3.3. And Gori's wondering whether we ought to make that a separate high-level section to sort of point or be able to point network equipment people to, rather than burying it at the end of the main endpoint implementation spec. Now, obviously, you can point people to a subsection as much as you can a section, and I'm sort of pushing back to Gori because I don't like the idea of adding a new section at this stage, which then bumps all the following sections on one. That means that anything else that's referred to any of these sections will be wrong, because this draft has been around a long time. So I don't really want to do this, but I support the idea of doing it if we'd have done it a lot earlier, and I'd just like some opinions. It's a possibly nitty point about section numbering, but maybe important. I don't know whether there's any discussion on the we can have on the list about that. And also, Gori's given me loads of other useful improvements. Then we had the review from Marku, which asked three main things. There was a fourth, which I'll say verbally. He wanted us to describe how ANA would allocate the remaining bit combinations of the three header flags that Accurate ECN used, and I pushed back on that on the basis that there isn't really or the working group doesn't want the capability negotiation of TCP to use the header flags. That was just something that came from ECN, from the history of ECN, and it made sense to do it with Accurate ECN to continue doing it for that. But it's not something we would want to have an IANA registry for those particular 3 bits. And also, there's no reason why they should be used just in combination with each other. They could, other people might invent other ways to combine them with other bits. And that, as it happens, they're actually combined with a SYN bit and the ACK bit, because they depend on whether it's a SYN or a SYN ACK or a data packet. So I don't think that would be useful. And I to be honest, I don't think IANA, even if we wanted to do that, could I don't think we could describe to IANA how to allocate anything like this, because this was all a bit sort of bit twiddling and a bit too complex for IANA to just give things out without working group involvement. So I push back on all of that. So that's that one. There was a useful point Marku made about an area in the draft that talks about forward compatibility of those same bits, the same flags, where in the draft it said only treat all other combinations of these 3 headed flags as, or treat all other combinations of the 3 header flags as Accurate ECN. So even though they're not 111 as Accurate ECN would say, all the ones that aren't used, treat them as Accurate ECN, and Marku suggested the words "if not otherwise understood," which makes it much clearer that they are for future use, and if some future use is using them, then you wouldn't make it Accurate ECN. I hope that's clear. I'm just reading Brian's comment. Yep, thank you, Brian. And then finally, we have a question about acts of pure acts, which is ongoing on the list, and I haven't seen Marku's reply yet, or I haven't seen a reply from Marku yet, and it's a sort of edge case in the draft, which depends on if there's also ECN++ being used. So I've suggested anyway we ought to take it out because this is proposed standard. Marku didn't like it because this is a proposed standard, and put it in the ECN++ draft, which it's only relevant to because it doesn't matter if you're not using ECN++. So we put it in that, which is experimental, and so take some of the text out of this one and put it in ECN++. And we would still leave the text in here about responding to to acts of acts, or there's this counter idea of responding at least every 3 CE marks on pure acts. So we'd still have that rule in accurate ECN, but some of the more detailed stuff about detecting duplicate acts that Yoshi helped us with would move into the ECN++ draft. Okay, that's that from Marku. There was another item he asked about, which was the to make it clear that it's not obsoleting RFC 3168, and Gori wanted the same point made, and so I've said, well, it's very clear this only updates RFC 3168, not obsoletes it, and suggested some changes to Gori, which Marku might want to look at as well to make it clearer. But RFC 6138 is still there and can still be used, but this is an update to it. So I hope that's all okay. Thank you. Next slide. Finally, just to list the current implementations of Accurate ECN, we have one that's just recently been merged up to v5.15 of Linux with the help of Neil Cardwell. We have Richard Scheffenegger's implementation in FreeBSD, which doesn't yet include the TCP options, and we have one in progress, quite significant progress in iOS and macOS for Apple. Thank you. Next slide. Sorry, that final one's video. And next steps, where we've come out of working group last call now, and we're now in the sort of post working group last call phase, where we as the authors have got to fold all the changes into the draft to address all the reviews. As I mentioned, we've done 2 of them. I'm halfway through Gori's, and then and we've got agreement with Gori on all of his points, and we're getting there with Marku. So thank you for all those reviews, and thank you everyone for your help, and hopefully that will close this off. Thank you. Any questions?
One clarification question. You said it's implemented in Linux version 5. What was it? 14.
15. Yeah.
15. Does it mean it's implemented for that version and you need to patch your kernel, or does it mean it's part of that kernel?
It's implemented for that kernel. No, it's not been upstreamed.
Okay, thank you.
But that is in progress. Upstreaming it is work we're aiming to do. Ilpo has actually said he'll help with that as well. He's moved on, but he says he'll help with that work as long as someone else helps him as well. And I think Neil is involved in it.
Thank you.
Neil is involved in it.
We can't hear you, Richard.
So if I may, this is Richard. I just wanted to give feedback on the comment again on X, because on the list, the comment was basically that it may trigger subsequent retransmissions of data packets, but I don't think we've had this discussion a long time ago already. I don't think that this will ever happen, because any new data that becomes available will be carried out by the sender anyhow, and X on X will only be happening at the very tail end when there's no new data available on either side of the session. And due to the way how ACONEX are triggered, they will be running down. They will be exponentially decay, and after 2 or 3 RTTs, there won't be any more ACONEX. So that's just my feedback on this particular comment. Thanks.
Any more comments?
And I assume you'll put that on the list, Richard, to Marco.
I have one question.
I will.
Mark, please go. Mark, I cannot hear you.
Yeah, Marco Koyo, for Richard, the problem was not that the echo, the ping pong effect, even though that is the problem because this happens during the congestion and it adds packets when there is a congestion. That is a minor problem for sure. But the problem is that if this feature causes fast retransmits, it's a problem. And then it should say, should not use without timestamps or SAC enabled. It should say must not use, because it also interferes or confuses fast recovery. It confuses limited transmit. It confuses PRR. It makes all of these to trigger extra packets, so making TCP more aggressive than it is supposed to be. And it breaks FRTO, and it's quite likely to break the AFL detection even with timestamps. It requires quite a complicated scenario, but still there is a scenario, or maybe more than one scenarios where it breaks it. So that is the point that I would like, I tried to make.
So if I may reply to this, again, we've had the discussion around Axon X, I guess 1.5 or 2 years ago already, very in depth, and we couldn't really figure out a way how this could trigger any of the fast retransmissions, data packet retransmissions that you're describing. So if you have a specific scenario in mind that could really turn out this way, please let us know.
Marco, yes, I will do. Hopefully this week, but if not this week, then soon after the weekend.
Don't run away. I have a quick question for you. Do you agree what was on the slide that this is actually a problem for ECN++ and not for accurate ECN? Because it can only happen if you use it with ECN++. And this is me.
It happens if we are sending an acknowledgement on a pure ACK.
Yeah, that's what ECN++ is about.
Because it's a extra duplicate acknowledgement.
But that's what ECN++ is about. So I think it's not for this draft. It's actually for the other draft.
But this draft specifies sending these acknowledgements on pure ACKs or as a response to pure ACKs. It specifies, okay, it uses it. It doesn't even specify. It doesn't give a normative reference that it would be even possible to ACK pure ACKs. The TCP doesn't ACK pure ACKs. We don't have any specification which says that this is even possible. So how can an implementer implement this draft using a feature that has not been specified?
So that is specified in the ECN++ draft. And that's why we are trying to cover this case here as well. But you're not expected to do it without also implementing the ECN++ draft.
Okay, but that's not enough for SAC enabled. You need to tell also how to reply when SAC is enabled, how to acknowledge in that case, because 6675 doesn't tell that. You need to also specify what is the timestamp to echo. These are quite obvious, but they are not specified.
That's maybe more a question for Bob. You're next in the queue, because I don't know the ECN++ draft by heart.
Well, I was just in the queue to agree with you, Mia, that what the accurate ECN draft says about acknowledging at least every third CE mark on packets without any data, without any newly delivered data, cannot apply unless you're also using putting ECN capability on those acts, on those pure acts. You wouldn't be acknowledging them unless they had ECN capability, and that's why it only applies if you've got ECN++, which adds that ECN capability. So if there's no ECN capability because you're not using ECN++, that rule wouldn't even come up. So you'd have to add that code when you coded ECN++, which is why I'm suggesting we move it into ECN++. But the requirement to acknowledge every third CE mark can still be in the accurate ECN draft. It just doesn't need to give all the details about it. It just needs to say, you know, if something like ECN++ were being used so that you did have ECN on pure acknowledgements, then you would have to acknowledge at least every third, and then refer to ECN++ for the details.
Okay, we are running out of time for this presentation.
Right. Yep.
I think one clarification question is ARC is experimental logic, right? Because ECN++ is experimental RFC. So
Exactly.
that maybe
Yep.
in the draft, maybe you can emphasize this is experimental logic in the draft. That might be useful.
Yeah.
Bob, next, generalized ECN.
Yes. Presumably you'll put up the
We are
slides,
running over time, so
yeah,
please
I'll be very quick. Right, this is work with Marcelo that's also been hanging in a holding pattern for accurate ECN for many years now and hasn't really changed. Next, I will just introduce the motivation for this because it's been sitting without much activity. The plot shows flows of different sizes on a log scale and their flow completion time also on a log scale, and you can see there the ones that take a second primarily due to retransmission timeouts on the SYN because of the SYN or the SYN-ACK being lost. And ECN++, the main motivation is to be able to put ECN capability on all TCP's control packets, including the SYN and the SYN-ACK, with many arguments within the draft on why that's okay, so that you don't get that variable latency, variable flow completion time. So the ringed part of that plot would disappear, all those bad spots. Next, and there's a table in the draft that lists all the control packets and retransmissions that RFC 3168 says you should not or must not put ECT on. And this table shows why ECN++ depends on accurate ECN. If you haven't negotiated accurate ECN feedback, you can still use ECN++. It still gives benefits, particularly on the SYN-ACK, where you can use ECN, but you can't use it on the SYN, except in one case on the footnote. And you can't use it on pure ACKs, but if you've got accurate ECN, you can. That hopefully explains some of the conversation we've just been having. I'll move on in the interest of time, but this table is in the draft. Next slide, please. All right, so as far as any recent changes concerned, there have been none really. It's stable technically, just editorial fixes. Next. And it's ready for working group last call. These slides were written before that conversation about bringing some new text into it, moving it from accurate ECN. So it's ready for working group last call, other than the possibility of moving that text over.
Any questions or comments? Any technical questions? So the chair is thinking that after we finish accurate ECN, we are start running working group Rust code on this draft. If you have any doubt or questions or comments, this is a good chance for you to speak up. Okay. Moving on to the next presentation. Thank you, Bob.
Thank you, Yoshi.
Chorus.
Okay, hello everyone. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP ACK rate request tar option. My co-author is John Crowcroft from the University of Cambridge. Next, please. So first of all, a couple of slides to provide context about the motivation and main features in this document. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, it may also contribute to suboptimal performance in some scenarios. For example, in so-called large congestion window scenarios, meaning a congestion window size much greater than the MSS, where saving up to 1 of every 2 ACKs may be insufficient. For example, when performance limitations may be in place due to asymmetric path capacity, or when we may want to further reduce the computational cost and network load of too many ACKs. And then there are also small congestion window scenarios, meaning a congestion window size up to the order of 1 MSS, such as in data centers where the bandwidth delay product may be up to the order of 1 MSS, where delayed ACKs will incur a delay much greater than the RTT. And also in transactional data exchanges, or when the congestion window size, congestion window decreases, the ability of requesting immediate ACKs may help avoid idle times and may allow faster congestion window growth. Next, please. So this is the main format of the tar option, the one that carries the value of R, which is the requested ACK rate, which means the number of data segments after which a receiver is requested to transmit an ACK. And then there's the special case of R equal to 0, which is used to request an immediate ACK from the receiver while keeping the steady state value of R. Next, please. So on the status of the draft, it became a working group document in February. So version 00 as working group document had exactly the same content as the last version of the corresponding individual draft. And today I'm presenting version 01, which aims to address comments received earlier on the mailing list, mostly on the topic of stretch ACKs, and then also a few minor additions and corrections. Next, please. So let's go through the updates. We have first a couple of updates already in section 3, which describes the behaviors for the sender and receiver. So here, in order to ensure correct operation when tar is used, we have added a couple of things. For the sender, we've added that a TCP sender must not communicate a value of R corresponding to an amount of data bytes to be acknowledged at once by the receiver greater than the receive window size or greater than the congestion window size. And for the receiver, correspondingly, we've added that tar option capable TCP receiver must ignore a value of R corresponding to an amount of data bytes to be acknowledged at once greater than the last receive window size that it has announced. Next, please. So the main addition in this last update of the draft is a new section, section 5, which is entitled Issues of Stretch ACKs. So here we start by explaining that tar may produce so-called stretch ACKs, which have been defined as ACKs that acknowledge more than 2 previously unacknowledged data segments. These may entail issues such as sender burstiness, slow congestion window opening, and lower frequency of RTT samples. So in section 5, we have 3 subsections which focus on these respective issues. Next, please. So on the first one, sender burstiness, we explained that it may contribute to router queue overflow and packet loss. So we have added some possible mitigation for the sender to use pacing, which requires an algorithm to determine the data segment transmission rate, which in this case would need to be commensurate with R. Next, please. Then the second subsection focuses on slow congestion window opening. Here the problem is that during slow start, the congestion window increases by up to SMSS upon receipt of an ACK covering new data. So then stretch ACKs or even delayed ACKs reduce the amount of ACKs received by the sender. So this in turn will reduce the rate of congestion window growth. It will increase transfer time and or reduce throughput. So one possible solution might be appropriate byte counting. That's IFC 3465. It might help solve the problem. However, as far as I understand, it is still experimental and not actually included in RFC 5681. So as a solution here, we've added that a TCP sender should not use star to produce stretch ACKs during slow start. And also, even if there are a few receiver TCP implementations that would transmit one ACK upon receipt of each new data segment, we have added that a TCP sender may use star with R equal to 1 for data segments transmitted during slow start. Next, please. Finally, in section 5.3, it focuses on lower frequency of RTT samples, which is due to the fact that we would have stretch ACKs in some cases. Then this reduces the responsiveness of the RTT estimate to RTT changes, and this might lead to having time-based packet loss detection becoming inaccurate. So in some cases, there could be unnecessary delays. Perhaps in other cases, it would be the other way around with perhaps spurious retransmissions. So here, as a first approach for mitigation of this problem, we've added that a sender should trigger an ACK being sent by the receiver at least once per RTT. And there would be at least two options to do that. One is sending a data segment with the TAR option with R equal to 0 at least once per RTT. The other one would be using R greater than 0, or perhaps, as Jonathan Morton wrote on the list, perhaps a sufficiently small value of R, which ensures that at least there would be one ACK per RTT.
I think, Mary, you might have been first in the queue.
I wanted to let Corey first.
Oh, okay. Okay. Corey, you are now first in the queue.
Do you have data to show that one ACK per RTT actually doesn't prejudice performance? Because we did experiments with Quick, and it really does slow down the performance when you have a bursty or other traffic in the return path. So do you have data for the one RTT?
Yeah, so we don't have data currently. Actually, this text here was somehow inspired by similar content in a related draft, which is in the context of Quick. So yeah, perhaps we may try to get some data. And well, this would be like some first approach. Perhaps we could go further and require more than once per RTT. But yeah, we need to work on this point.
Okay, the same comment applies to your ABC assertion, because I think we saw the same effect when we look at packet traces with ABC and return bursts in the ACKs. ABC didn't really fix it. ABC helped, but the little delays when you had a big R caused a problem, performance problem. Do you have performance data for that one either?
Okay. Okay, thank you.
Okay.
Yeah, hi, I'm Mia Kulevin. Two comments. One about this discussion on Quick. So we have the discussion currently how much X that should be, and we might end up saying more than one per round trip time. So you should watch that discussion.
Okay.
And my other comment was on the burstiness. You say using pacing is mitigation, but for all the other cases, you actually use normative language, and for pacing, you don't.
Yeah, that's true. Yeah, so perhaps to be consistent and have something actually useful, yeah, I guess we should add some normative, well, 2119 language to add also for the pacing,
Okay.
like may perhaps at least, or yeah, at least may, I guess.
Yeah. Okay. I mean, I think that would be good. I was just wondering if there's a reason why you're not using it, or if you have
Yeah.
concerns about pacing. No, you don't. Okay.
Yeah.
Let's do that.
Thank you.
Please continue.
Okay, so then I guess we can move to the next slide. So finally, just a few minor additions. In section 1, we were mentioning that the requirement level for the support of delayed acts in RFC 1122 is should. So we added also that this was subsequently also reinforced in RFC 5681. And we also added in section 1 a reference to RFC 9006, which is the document entitled TCP Usage Guidance in the Internet of Things, since also in section 1 we have a motivating use case for this draft for TAR, which comes from an IoT environment. And finally, in section 4, we have updated one sentence, as you can see on the slide. Mainly the point here is that in the draft, we state that the support of the TAR option can be announced in segments that do not have the SYN bit set. So in order to avoid implying otherwise, which was happening before, now we have modified the sentence accordingly. So next, please. Well, that's everything from my side. Any other comments or questions?
This is Yoshi. This is just my personal comment. So let's say we set R equal 5 or 6, rather big value, and timeout happens. Then congestion window becomes 1. And then if the receiver think R is 5, then the performance will be degraded. What do you think about this thing?
Yeah. So I guess this is due to the new text we've added in section 3. Yeah, so that's a good point. I guess we need to double think about that. I don't know how to provide some sort of safety margin there in the operation. But yeah, that's a good point, and we need to think about it. Thank you.
So,
Richard, you're next.
So Richard, my comment really was that, quite frankly, for most of the things that you've described, the sender is actually the entity in control of both what it is sending, meaning it knows if it is expected to send out a larger number of packets, the number that is to be acknowledged or not. So therefore, it is also under the purview of the sender to set the TAR option accordingly. If, for example, it has only a very small congestion window. So I maybe would suggest to have a more generic description that it is the responsibility of the sender to choose a TAR option, temporary with R equals 0, or even longer term, say for example during slow start, that makes sure that the sender receives the expected acknowledgement rates that it is needed for all its mechanisms to work properly, rather than make it one by one description of what an implementer should be doing for each and every of those specifically defined circumstances. Thank you.
Okay, thank you. Yeah, thank you.
Bob?
Just wanted to, I think, correct you about whether RFC 5681, the congestion control RFC uses ABC. It refers to the ABC RFC, which is experimental, but it recommends using, at least the part of ABC that is the algorithm. It gives the algorithm and recommends its use. So, and that's obviously proposed standard. So I don't think you can call that experimental anymore.
Fair?
Okay.
Okay. Thank you.
Thank you. So next presentation is agent.
Hello, everyone. I'm Wei Wang from China Telecom. And next slide, please. Yes, I have give this. I have give the presentation of this draft at IETF 150, and after the presentation, we received a lot of suggestions and comments from TCPM experts, and after doing some homework, we have modified our draft, and we also have some considerations on MPTCP and TCP EDO, and we want to show our modifications and considerations here. And next slide, please. Yes, firstly, we add some contents on the introduction, and we add the load balance scenario, because we think our solutions can support this functions, and can alleviate the bottleneck problem of the typical load balancer. And we also add the descriptions of MPTCP, and also shows the reason why we do not use MPTCP to meet our demands. And next slide, please. We also split the service affinity option into two different options, and because we think this modification can reduce the length of service affinity options, and avoid the waste of TCP header space. And which option to use depends on whether the server receives an IPv4 or IPv6 unicast address. And next slide, please. Yes, because in the working group mailing list, we received some suggestions about our draft and MPTCP. So we do some homework about MPTCP. We think in the terms of function, it can solve the scenarios we proposed, but actually we prefer to perform the fast service path handover based on the traditional TCP three-way handshake process, and the TCPM can support this function, but it needs to establish the connection at first. And the solution we proposed just set the SAF flag in SYN packet when the sender sends the unicast IP address. And this flag is to identify the sender can support service affinity option. And when the server which receives the SYN packet and it supports the service affinity option, it will send TCP packet contains its unicast IP address in the related service affinity options to the sender. And then the sender can establish the connection to the server via the unicast IP address. And the whole process can be completed during the TCP three-way handshake. And next slide, please. Yes, about the TCP EDO, it can extend the total. It can extend the space of the TCP header for non-S1 segments, and but it has the similar consideration with the TCP/IP because our solution hope to support the fast handover during the TCP three-way handshake, and the TCP EDO only can support this function after the connection is established. So we think it is not match our solution so well. And the next slide, please. In conclusion, we prefer to define a solution which could support fast handover and complete the path choice during TCP connection establishment. But both MPTCP and TCP EDO need to establish a TCP connection first. So we think they are not match our solutions so well. And we also think about the extension of TCP header. We think the service affinity option and EDO supported option can be carried in SYN, ACK, and packet, and other options that are not related to fast handover can be carried in the extended part, and this allowed for both fast handover and TCP option available space extensions. And next slide, please. That's all. And any comments or suggestions are welcome. Thank you.
Any question? This is Yoshi. This is just personal comment. So it seems to be, correct me if I'm wrong, but what you are suggesting basically redirecting connection or migrating connection. And so it's more like a big idea. So, and then service affinity is one of use case. So I think the option name may be, more generic name, maybe more preferable, but this is just personal opinion. And you should think about security. If this technology is standard as it is, I can easily use this technology to steal someone's connection.
Okay, thank you. And yes, we think a security problem is also very important. And because TCP is very complicated, so we also hope TCPM experts can give us a more helpful suggestion about security, such as tell us which RFC or which draft document can help us more fitable to use useful for our draft, and so that we could refine it quickly.
Yeah, as you are from Taiwan Telecom, currently we just want to focus on the faster handover. So we compare the existing solution. So for example, the MPTCP and the TCP EDO. We think the existing solution all need to establish the connection first, so it cannot meet our requirement. For the security concern, we think we can add it later for some cookie for the server or for client to authenticate the server's identification. So this is the second step for the future update. Okay. First, we want to solve the how to encapsulate the survey option. Okay.
Mia Kulevent. Yeah, so I understand your use case, and I understand the need to have like this fast handover, but I'm also concerned about security, and I don't see a solution how to solve that security other than the solutions that were proposed, like using MPTCP or using EDO, or another solution that was proposed last time by Lars was like moving it to a different layer that actually has some kind of security protection. I don't know how to solve that problem in like a pure TCP option.
Okay, thank you. We think we will do some homework about the security problems.
Ian Sweat, Google. As an individual, yeah, I was going to just plug the usual question of whether this is at the right layer, or at least whether it needs to be at this layer, just because this seems very difficult to deploy.
Yeah, Lars Eggert. So we've seen at least, so my memory is bad, but I remember at least one earlier presentation, and I now got reminded I actually said something last time. So there was certainly one prior presentation, maybe more. I'm kind of wondering what the trajectory is for this document, right? Because it doesn't really seem like it's seeing much implementation interest, and it doesn't seem like there's much adoption interest. And I'm kind of wondering, you know, how many more times do we want to see this presented without it getting some sort of traction? It's, you know, it's we can present it for information, but it seems like sort of dissatisfying to do that.
If I understand correctly, you are concerned why do we search the solution on the chatbot layer? So I think we have present the main scenario in the last meeting. Currently, I think you have now the CATS working group has established. You know, he want to optimize the traffic based on the network topology and the status of the server status. So some server information, status information will be transported within the network, and the edge router of the edge router within the network will select the best server based on the network topology and the server state. So if we do not have such a solution, the edge router must keep the mapping table for the final server selection. So I think such solution is not extensible, because there are many servers and many clients will access the server. So the edge router must keep the many mapping table on it. So we think if we can switch or hand over the connection correctly, there is no necessary to establish the mapping table at the edge server. So I think this is coupled with the requirement with the CATS working document. This is the background. Okay.
Lars Eggert, so so CATS got chartered, and I think they are, I don't know if they met already, but I think they're sort of in their first phase of work, very phase of work. I would be very surprised if CATS had a requirement on TCP changes. Right, so they might determine that they have a requirement on TCP changes, and I think at that point they can come to TCPM and say, hey, we would like you to consider working on something in this space. But I don't think CATS is sort of contingent on us doing this, right?
I think the charter for the CAT will not mention the TCP extension, but I think they will. I remember they have mentioned the service affinity solution. You know, our current proposal is one kind of the service affiliate solution. So, yeah.
So I agree that you're also using the word service affinity in your draft title, but I don't. So for an adoption, because I guess the goal for presentations in the working group is generally that at some point, right, the question is, would the working group be interested in adopting this? And I'm not like asking that question now, but I'm asking when are we going to ask that question, because I don't see a trajectory where the answer is going to be yes anytime soon. And right, CATS might be chartered to work on solutions in the space, but I'm very sure that CATS is supposed to deliver a solution for existing traffic and not for new traffic that needs to have certain packet header fields present to be steered. Because if CATS were depending on something like this, it would be a long time before CATS could steer anything.
So I think it is better to that we make the presentation also in the CATS and get some comment, and we can compare the other solution within CAT for the service application, service flow application. So if our solution is better than others, I think the TCP extension is necessary. We have compared the existing flow application solutions. Okay.
Even if CATS decided it needed something like that, this group would still need to agree that it's doing it.
Yeah, I know.
So that's why. So a requirement, quote unquote, from CATS is sort of, it would be nice to see, but it by no means means that it will also get adopted. Right. So that's what I'm saying.
I think yeah. Currently, we think the current solution may be the best solution for the flow affinity, you know, because the current solution requires the mapping table on the edge router. It is not extensible.
I don't want to cut anyone off, but I do want to note that we're running out of time, and the longer we talk, the less time Yoshi gets.
So since you don't want to cut me off, I'm going to say one more thing. No, I'll be quick. So I mean, CATS, right? Like, or most IETF working groups, they want to like do something with the current traffic in internet, right? So CATS wants to steer traffic in a certain way, and that means traffic that is already in the network, and that means and maybe it sort of is not going to be as optimal that it could be if something like this happened, but it also can't really afford to wait for this to get enough deployment that a sizable fraction of the traffic will have it. So they got to work on mechanisms that work with the traffic as is now, right? Because otherwise they're not going to have anything that works. That's the point I'm trying to make.
Okay, rather one point. Can you clarify what you want to see in this stuff in the future version?
Ideally, I would like to see the usual like interest from implementers and people who are deploying things on the network that's saying, yes, we're going to do this. And I think then we can have a discussion about, does the working group want to publish this or adopt it, I guess is the first question, right? So that's ideally what I would want to see. Like, hi, I'm from XYZ and I have a deployment and this would really solve our problem here and we're going to ship this ideally, right? That's sort of.
Yeah, the work from the CAT is just beginning. So our proposal are just research. We have not implemented now. I think we can discuss more closely with the CAT and compare with our solution. If they decide that our solution is the best, we can come back to the TCPM to problem. Okay, thank you.
Thank you. Oh. You want to?
Go ahead.
I think I just wanted to make my point a little bit more clear. So the security concern I have is that anybody can send a FIN from a spoofed or with a spoofed address, right? And then just stop the connection and redirect the traffic to like your own server to any server, right? And TCP is not a very secure protocol, but this makes it even worse. And I don't think there is any solution that to this problem in the TCP layer as a TCP option. So I recommend you, in order to solve your problem, which is a good problem to solve, to find a completely different solution and not thinking about TCP options. Sorry, just to be very clear here.
So currently you are concerned mainly in the security part. So we will do more research later and to find if there are any optimal solution to cover your concern. Okay.
I mean, please do more work, but I don't think you will find a solution that enables this as a TCP option. I think you should try to solve your problem on a different layer and a different protocol.
We have compared maybe. Okay.
Because I understand that like this is like from a performance point, it's the optimal solution. But this security problem is very severe, and you won't fix it. And if you can't fix it, we cannot standardize it.
Thank you. Yoshi, can you stop presenting your slides and I'll run them for you?
Yeah.
Okay. I can't take over the. Oh, I guess I can.
Okay. You can do it. Right?
No, I can.
Yeah, I can stop it.
Oh, yeah. Thank you. Wonderful.
Okay. Hello. My name is Yoshi. Today I'd like to talk about aggregate option for scene option space extension. Next slide, please. So the purpose of this draft is very simple. It's try to provide a solution for limited option space in scene segment, which is very critical issue. This is because all options to be used in the connection should be appeared in the scene. Otherwise, we cannot use this feature. That's the semantics for TCP. Next slide, please. So I think this is not a new issue.
So Yoshi, that's not true. We have options that are sent later.
Which option?
UTO.
Oh, I see. That's one exception. I didn't know that. Okay. Okay, then this is not a new issue. I think there are several approaches that's proposed before. And one type of approach is to extend the header format for scene segment, such as overriding data offset field in TCP header. Then next type of approach is sending multiple scene packets or a scene-like segment. And by sending multiple segments, we can carry more options. And some approach combining these two approaches. Next slide, please. And then, but our approach takes different things. Basically, what our approach does is to define aggregated option, which is new TCP option used only in scene segment. Since we are just defining a new TCP option, we don't modify header format. We don't use additional segment. And then we believe we don't change any TCP semantics. Please go to the next slide. So the concept of aggregate option is like this. So we know some option in segment are just used for indication of the feature. Such example is SAC option or first option cookie or EDO or tar. In these options, basically in scene segment, there is these options, but it's used for only indication of the feature. Indication of the feature means I want to use this feature. That's about it. So this is basically 1 bit information. Then, but we have to use 2 or 4 byte, what could be more option space to carry this 1 bit information. Especially in case of experimental option, we have to consume option space at least 4 bytes, what could be more. And then the basic concept of aggregated option is to aggregate these options into a single option so that we can save more option space. Next slide, please. Then aggregated option carries aggregated block, which consists of 1 byte. 8-bit. And then the first 2-bit of aggregated block indicate group ID, so it's just 2-bit. And because it has 2 bits, we can have 0 to 3 group ID. And the rest of the 6-bit indicate each TCP option kind. So for example, 3rd bits of group ID 0 indicate option X, or 5th bits of group ID 2 indicate option Y, something like this. And the mapping between option bit and the TCP option kind will be maintained by IANA. So since group ID has a 2-bit, and then each group ID has 6-bit, we can support 24 options in this format. Okay, next slide, please. And then by using aggregated option, we can carry from 1 to 4 aggregated block. Okay, next slide, please. And this is very simple usage for aggregated option. In this example, clients send normal options such as timestamp or window scale. And at the same time, it's sending aggregated option. In this case, bits for option A and option B is set. And then server send back SYNAC. And in this case, inside SYNAC, there are normal options such as timestamp or window scale. And then also, it has aggregated option, and then bits for option B is set. In this example, option B will be used in this connection because it's negotiated. But option A is not negotiated. So this is very simple example of aggregated option. Next slide, please. And then deployment of new technology is always tricky. So I have several deployment strategy for aggregated option. One strategy is deploy aggregated option with newly defined option. So when new option is defined, we can ask implementators to support aggregated option. And because if the new feature support aggregated option, and so that's if this new feature is deployed, at the same time aggregated option is deployed. Another approach is sending original option format and aggregating option simultaneously in syn segment, as long as we have option space. And then if aggregated option is sent back in SYNAC, then we can cache in this information and use it for future connections. In future connection, we can use only aggregated option. That's one strategy. Okay, next slide, please. Yes.
Now it's my question to ask you something about Lars Eggert, about options we already have. Do we have an option that where the value is cached across connections?
Sorry, what do you mean?
So, I mean, can you think of an existing TCP option where we cache the existence or the value that was negotiated across connection instances? Because I can't.
What about TFO? I mean, it's not an option, but it's similar.
True. Actually, that might be the only one. Yeah. So I was wondering if we had a existing, because so far TCP connections are sort of, there's no history kept between them really, other than maybe some routing-ish.
How about MSS?
Yeah, I'm mostly wondering, like, what if your thing ends you up, your next connection instance ends up at a different server, and that doesn't have that new stack yet, and you think so. You talk to one server at an IP address, and you talk to the different backend server at the same IP address later, and what happens if you think that person or that server speaks it and it doesn't? But we don't have to like debug this now. So I'm interested because a long time ago when we talked about this, because everything we talk about every 10 years, right, in TCP, I had a very similar idea that I never wrote up. So I'm kind of following along and try to remember what I thought back then. But yeah, we should chat offline.
Okay, thank you.
Andrew McGregor, Fastly.
Yep.
I think for a large operator, that's not actually that hard of a problem. It's just a deployment scheduling issue, and yeah, you basically you make sure that your load balancing groups include things with the same options, right? Or delay turning it on until everything has it, one or the other.
Richard, you're up next.
My question was, have you run any look at the benefits of just implementing like bit field, individual bits for individual options, versus also including things like MSS and window scale into the aggregated option? Because if this, my idea, so if this happens and gets deployed, eventually, hopefully, most of the end hosts will support this, and you would probably get more benefit by also rolling in some of the more common options like MSS and window scale into this aggregated option as a multi-bit field or as a dedicated group ID or something like this. So I would like to see some analysis about the benefits to be had there.
Okay, thank you.
Thanks. Martin Duke, you're up next.
Yeah, hi, no hats. Like Lars, I thought about this like 10 years ago, and how to design was not nearly as good. So I'm very intrigued by this. I think it's much more elegant and is much less clunky than clunky is not the right word. Doesn't have a lot of the difficult consequences of some of the other option space solutions that people come up with. So this is great. I think Richard has an interesting point about some of the more complicated options that have data fields with them. Maybe we just produce like two options, one that's the bit field and one that is like a compressed form of like the numerical options of the ones that have, you know, value fields in it. I think that I'm glad you thought a little about the deployment path. I think the ideal solution is that a bunch of people decide this is a great idea, and you know, a bunch of people with implementations think this is a great idea, and then it just sort of takes off as sort of a future-proofing method. But if not, I think we do have to think a little bit about all the different option combinations. What are the use cases that are out there where option space is a problem, and where can we accept, and in those use cases, which options are nice to have and which ones are not? Because you could compress the ones that are nice to have, and then you maybe have some performance penalty, but there are other ones that you really got to have, you know, security related ones and whatnot. So that would be an interesting discussion if we get there. But I'm curious if people are like excited just to implement this, and if so, like we don't have to worry about deployment quite as much. Thanks.
Lars, did you have something else?
Yeah, I did. Lars, I guess what Richard said sort of is more along the lines what I thought, that, you know, I think my working title was, you know, I'm a modern TCP stack option, right? Where you roll in a bunch of stuff that we sort of think a modern TCP stack turns on anyway, and you maybe even roll in some values. If you want to take it to the extreme, it would be like a bit that says, you know, I'm TCP version 2. But something like that, right? I think there's a space here, especially I think the world has moved on because our ability to chip stacks and control like large fleets has changed since maybe the last time we talked about this. And so maybe there's solutions that are possible now that weren't possible back then.
Andrew McGregor, Fastly, or another possibility, a TCP profile option, which gives you, I don't know, 6 or 7 bits of here's an entry into the catalog of common option sets. I'm using these.
Bob is still on the list. You have one more slide, right?
Yeah, just one more slide.
Okay, Bob, do you have something you want to say on this?
I'll let him finish.
Yep.
Shall I move one?
Yeah, why don't you do? I think so.
Okay. Okay, there are updates, updates from the previous version. So previous version in this draft indicates delayed option negotiation scheme, which utilize third segment and fourth segment to negotiate option parameter. But I removed this scheme from this current version because this is complicated and we don't have a use case for that one. So right now, the current draft contains only aggregated option for simplicity, and we can see some use cases for that. Okay. this is the last slide on my presentation. So I just presented the aggregated option, which aggregate multiple TCP options to save option space in scene segment. And I think this is a practical approach. And if people don't like this approach, maybe it's time to think about previous approach, such as extending header format or sending multiple scene segment, because that's a way to solve the issue. But if needed, we can think about both approaches at the same time. While we are thinking about aggregated option, then at the same time, we can think about extending TCP, like header format or sending multiple scene. And because aggregated option probably will not create any conflict, because all it does is create a new option. So it should be okay. So, but at least I would like to see some progress in this problem space. That's the motivation with this draft. So thanks so much.
Thank you. And that is all the time we have for TCPM. Bob, you didn't mean to still be in the queue, right? I just wanted to check.
I did. Yeah, I said let him finish, and then I'll ask the question.
Okay.
Oh, can I? It's very quick.
Sure. Yeah.
Okay. Briscoe. The draft says the aggregated option must be only used in SYN segments, which I assume means segments with the SYN flag set, because that can be ambiguous for a start. But that's not my question. My question is, how complicated would it be to not disallow it being used on another segment, say, for instance, the third act of the handshake? So, for instance, if the client doesn't offer some option, the server wants to use an option, and then the client says, yeah, well, I can do that as well, but I didn't know you wanted it.
Sorry, I couldn't pass the question. Maybe
I didn't hear it fully. I think it was.
Maybe we can.
I think that was kind of, yeah, maybe take it offline. I think that was along the lines of the deferred negotiation, maybe, but I'm not sure.
It's more where the server starts the negotiation, not the client.
Okay.
On the SYNAC.
Okay. Maybe would you mind contacting Yoshi directly or on the list?
Yeah.
Okay.
Yep.
Okay. Thanks, Bob. I appreciate it. Okay. Have a good one.
Okay. So this is the end of presentation. Yes. Okay. This concludes the meeting of this working group meeting. So thank you so much, and see you in San Francisco.